So hello guys. So this is trigonometric question. I want to prove that this is equal to this. So how do we do that? Let's keep this aside. It's either you turn this to this, no problem, or you turn this to this. But I would prefer to turn this to this because I think that should be easier. Now, from the identity, tan A minus B. Do we remember? Tan A minus tan B divided by 1 plus tan A tan B. I hope you remember this identity. But here, what's our A? 1 over 4 pi, which is same thing as pi over 4. So here, if we have tan pi over 4 minus theta over 2, it's going to give us tan pi over 4 minus tan theta over 2 divided by 1 plus tan pi over 4 tan theta over 2. Do we get that? This is the identity that we know. So I'm just saying, if this is our A, if this is our B, substitute it into this. So now, I know we want to talk about square, but I'm starting from this. Now, so here we have tan this over 4, tan pi over 4. Pi over 4 is 45 degrees. Tan 45 is 1. 1 minus tan theta over 2 divided by 1 plus tan pi over 4 is 1. 1 times tan theta over 2, you have tan theta over 2. Do we get that? This will be 1 times tan theta over 2, which is still tan theta over 2. So this is tan pi over 4 minus theta over what? Over 2. Do we get? So, but we need square. If we square this, and also, so we square this. Do we get? So, if we have a minus b square, it's same thing as a square minus 2ab plus what? B square, right? So, the numerator becomes a, assuming this is a minus b. So, here we have 1 square. If you square this, you have 1 square, which is 1 minus 2a, 2 times. If you have a minus b square, you have a square minus 2ab plus b square. So assuming these are a minus b, so you have a square minus 2ab, that's 2 times 1 times this. 2 times 1, 2 times b, theta over 2, plus b square, tan square theta over 2. Are we together? The denominator is plus. If this is plus, this will be plus. So here we have 1 plus 2 tan theta over 2 plus tan square theta over 2. Are we together? So here we are, this guy is going to turn to what? 1 minus 2 tan theta over 2 plus tan square theta over 2 divided by 1 plus 2 tan theta over 2 plus tan square theta over 2. Do you get that? So that's that for that. This is now equal to this, and I hope you are not confused or where we started from. I'm not touching this. So now what are we going to do now? Since note tan theta equals to sine theta over what? Cos theta. Or let me say tan equals to sine over cosine. I hope you are familiar with this. Tan is sine over cosine. So all this time we are going to replace it with sine over cosine. So here we are going to have 1 minus 2 tan theta over 2, that's sine theta over 2 divided by what? Cos theta over 2 plus tan square theta over 2, that's sine square theta over 2 divided by cos square theta over what? Over 2. Are we together? Over 1 plus 2 sine theta over 2 divided by cos theta over 2 plus sine square theta over 2 divided by cos square theta over what? Theta over 2. Do you get it to that point? I'm changing the tan to sine and cosine function instead of tan function. Now, because we have common denominator, except for this one, we have cos theta over 2 cos. So it is, let's make it very easy to eliminate. Now, we can't be looking for a way to eliminate sine because even our identity is in sine function. So it is cosine we need to eliminate. So how do we do that? We have to multiply everything, like multiply the whole denominator by cos square theta over 2, and the whole numerator. If I say everything here times cos square theta over 2, and I also say everything here times cos square theta over 2, I've not altered the question, because it's just like I'm multiplying the whole, and the whole is just like times cos square theta over 2 over cos square theta over 2. Yeah, this multiply the whole numerator, this multiply the whole denominator. Do we get? So I'll now be saying 1 times this times this times this, 1 times this times this times this. So I'm using this is just 1. What I just clear now is 1. Cos square theta over 2 divided by cos square theta over 2 is 1. But I'll just use the numerator to multiply this, denominator to multiply this. So now 1. So in a nutshell, the meaning of that in a nutshell is that you are using cos square theta over 2 to multiply all the terms in the expression. 1 times cos square theta over 2, you have what? Cos square theta over 2 minus 2 sin theta over 2 over cos theta over 2 multiplied by cos square theta over 2 plus, let me write it somewhere. You are using everything to multiply cos square theta over 2. So 1 times cos square theta over 2, you have cos square theta over 2 minus 2 sin theta over 2 cos theta over 2 plus times cos square theta over 2 plus this one sin square theta over 2 divided by cos square theta over 2 multiplied by cos square theta over 2. That's the numerator. So for this denominator, 1 times cos square theta over 2, you have cos square theta over 2 plus 2 sin theta over 2 divided by cos theta over 2 multiply by, use this one to multiply cos square theta over 2 as well, plus the last one sin square theta over 2 divided by cos square theta over 2 multiply by, we are using the third one to multiply cos square theta over what? Theta over 2. Do we get that? So this question now becomes I think it should be able to contain this space, equals to, this one becomes cos square theta over 2 minus, now cos theta over 2, no, this is square, cos square theta over 2 over cos theta over 2 will cancel one out of this. So what do we have left? Here we have 2 sin theta over 2 cos theta over 2, 2 sin theta over 2 cos theta over 2. Are we together? So here what do we have? Here we have cos square theta over 2, cancel cos square theta over 2. What do we have? We have sin square theta over 2 plus sin square theta over 2. Everything over, same thing happens here, cos square theta over 2 plus, this one will cancel one of this, so we have 2 sin theta over 2 cos theta over 2, 2 sin theta over 2 cos theta over 2 plus, this cancel this, plus what? Sin square theta over what? Theta over 2. So this is where we've obtained. Now cos square theta over 2 gather this together with this plus sine square theta over 2. Then we have this left minus 2 sine theta over 2 cos theta over 2 divided by cos square theta over 2 plus sine square theta over 2 plus, I'm gathering this together. So this one plus 2 sine theta over 2 cos theta over 2. Now note cos square theta over 2 plus sine square theta over 2 equals to 1. I hope we remember. It can be theta, it can be x, it can be anything. Once these angles are the same, cos square angle plus sine square same angle equals to 1. I will know that 2 sine theta over 2 cos theta over 2 equals to sine theta. Let me prove this second one for us. We remember that sine 2 theta equals to 2 sine theta cos theta. We remember this. Now, if I want to reduce, change the angle to half angle. If sine 2 theta is 2 sine theta cos theta, now if I want to say over 2, this one 2 over 2, if I'm dividing the angles by 2, so this one will remain sine theta, then 2 sine theta over 2 cos what theta over what theta over 2. So this is where this is coming from. So I can now replace this guy with cos square theta over 2 plus sine square theta over 2, that's 1, minus this is what? Sine theta divided by this, and this is 1 plus this is what? Sine theta. We've proved it that this equals 1 minus sine theta over what? 1 plus what? Sine theta. So that's that for that. Now let's move to the next question. So we want to use the Moivre's theorem. Okay, like we want to break this sine with power of 5 theta to function of sine and cosine as a product of multiple angles. As a product of multiple angles, like what you are trying to say in a nutshell is that now in calculus, for you to integrate this is very difficult unless you use reduction formula, or you can use Moivre's theorem to break it down to something like what they are trying to say. Like we want to turn this thing to something like, okay, the final answer will now be sine theta plus sine 2 theta plus probably sine theta or sine 3 theta. Like we want to reduce it to look like this. It is very easy to be integrating something like this. Like I say, powerful tools. The idea we are going to use a powerful tools to even use in calculus to reduce all this big power of trigonometry to something like this. So if you have something like this, they are very easy to integrate. So now the question now saying we should do that, break this down into sine and cosine function of multiple angles. So what we are going to do now, the first thing is that, and we are given that z should be what? What's our z? It says z equals to what? Don't forget cos theta plus what? I sine what? I sine theta. Some of you don't forget is r. This is the formula r. Yeah, but we are, since you are dealing with trigonometry, we are using a unit circle to prove it. A unit circle is when the radius is 1. Like it's a unit. If you are using a unit to show it, then it is balanced for whatever form of circle, whether 2 units or 3 units. But we cannot be using 3-unit circle to confirm a formula. What if they now give us the one that is of 2-unit circle or 5-unit circle? But if we use the one with of 1-unit circle to prove something, then it can what we obtain can be done for whatever unit circle, because 1 is just like a balance scale. Do we get what I'm saying? 1 is just like a balance scale. That at the end of the day, if we use that thing we prove for a circle that is 5 units, what will just be added at the end of the day is times 5. Do we get? So like 1 is like a balance case. So we are making use of a unit circle. So that's why this radius is 1. So that's why we have z to be what? Cos theta plus what? I sin theta. So I'm saying that so that I won't be confused. The formula is still this. But because you are making use standard, we are using the standard, which is a unit circle. So our R is 1. So we obtain this at the end of the day. So now, what you are going to do now is, so assuming this is, if you are using 2-unit circle, whereby this R will be 2, the formula we are going to get, we cannot, that formula will not be a standard. That formula will be unique to 2-unit circle. Yes, it won't be standard. But if this is just it, there is something I want to say. Yeah, whatever we get using this one is balanced for whatever unit circle we want to do. Yeah, because the only thing that will difference is now that we just bring our R in. If it is now 3-unit circle, we use 3. If now 5, we use 5. But we can still apply that same method we apply for a unit circle. I don't think you are getting at me, but we don't have much problem on that. There is no much problem on that, so let me not complicate matters now. So here we have z equals to r, but we are using the standard, which is a unit circle. Even this formula, cos square theta plus sin square theta equals to 1, they make use of a unit circle. Yes, that's why we have them to be equals to 1. If they are making use of 2 units, probably you should be having equals to 2. But the standard is a unit circle. Do we get? So that's why r here is also 1 radius. So here we have z equals to cos theta plus what? I sin what? I sin theta. Now, listen. If these are our z, now we need something that we need a formula that contains sine or cosine. It depends. Okay, now if z is this, that means 1 over z will give me cos theta minus I sin theta. Let me quickly prove this. Now, if z is this, then 1 over z, that will be what? Cos theta plus, that will be 1 over cos theta plus I sin what? I sin theta. Then multiply by the conjugate as if you are rationalizing. Yeah. This times the numerator, we have cos theta minus what? I sin theta divided by, this is cos theta times cos theta, that's cos square theta. Know this difference of 2 square. This times this will cancel this times this, then this times this you have minus I square. What's I square? Okay, what's, this will be minus I square sin square, I square sin square theta. This time this I square sin square theta. And what's I square? I square is minus 1. Yeah, I hope you are not a novice of that. So this guy at the end of the day is going to give us cos theta minus I sin theta. Are we there? Divided by cos square theta minus times minus, and that's plus sin square theta. And don't forget the trig identity. Cos square theta plus sin square theta is what? 1. So this divided by 1, we have this. So that's why we have 1 over z to be equals to cos theta minus what? I sin theta. So now, what we are going to do next now is z minus 1 over z is going to give us, what's our z? Our z is cos theta plus I sin theta minus 1 over z. These are 1 over z minus 1 over z cos theta minus I sin theta. Are we together? So cos theta we cancel, minus times this, it cancels. So here we have what? I sin theta minus times minus plus. I sin theta plus I sin theta, we have what? 2I sin theta. So we need, why we are saying z, the reason we look for 1 over z and subtract is to get something that contains sin theta. Do we get? If this question is cosine, then we do plus z plus 1 over z. We do z plus 1 over z. This we cancel, then we now have cos theta plus cos theta. Here will now be 2 cos theta. We now be working with cosine. But because it's sine, so as to avoid getting cos. Do we get? So getting cos is not a taboo. No, the question says sine and cosine function. Now, note that the question is not trying to say your answer should contain sine and cosine function. Like that statement, sine and cosine function is like a standard way of asking the question that, okay, your answer should be within sine and cosine. So like it can be sine, there is no problem, it can be cosine. So it's like a standard way of asking the question always, sine and cosine function, sine and cosine function. But because this is sine, we need sine identity. If it is cosine, we need cosine identity, whereby here instead of subtraction, we'll be doing addition. Do we get? So by doing addition, this sign will cancel. We have cos theta plus cos theta to give us 2 cos theta. But because we need sine for the sake of the question, so we are doing subtraction so that cos will cancel. Then we now have I sin theta plus I sin theta. And that, don't forget, it's minus that's here. So I sin theta minus minus plus I sin theta. We have what? 2 I sin theta. Now, what do we have here now? We have z minus 1 over z equals to what? 2i sine what? 2i sine theta. This is where we get to. Are we together? Now, how can we bring in this to this? Now, it's by taking the fifth power of both sides. Taking the fifth power. Sorry, let me write it here. Z minus 1 over z, take the fifth power, equals to 2i sine theta. Take the fifth power of this one. Are we together? Now, this one will give us now 2 raised power 5, 32. I raised power 5 sine. This one will give us what? Sine. Do you see that? We can see our question is now inside, right? So that means whatever we get, we just make this guy the set of the formula. Are we together? So now, don't note that I raised to power 5 equals to I square. Sorry, I raised power 5 equals to I raised power 4 times I. Right? And I raised power 4 is I square. Then here we have times I. What is I square? Minus 1 square times I. Minus 1 square is 1 times I equals to I. So I raised to power 5 is same thing as I. So we are going to replace that I raised power 5 with I. If you don't know how we get I, go and watch my video on complex number. I raised power 5 is I. So here we have Z this to give us what? 32i sine 50 theta. Are we together? So now we need to expand this guy using binomial theorem. Yeah, we need to expand this guy. Please go and watch my video on binomial theorem so that you will be able to expand this yourself. But I will only teach us a trick now. A trick, just a trick. Now listen. So this here, the first one, z will carry the power of 5. Are we together? If it is minus here, then the first number will be plus, the next one will be negative. It will be plus, negative, plus, negative, plus, negative. If you have minus, assuming if it is plus, everything will be plus, 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 plus. But if it is minus, you have plus, negative, plus, negative. So the first one is plus, then negative. Then z will reduce by 1, then multiply by 1 over z. Let me give it space because of coefficient. Z will reduce by 1, multiply by 1 over z, plus z will reduce by 2, multiply by, you will square this, 1 square is 1, z square, minus z will reduce by 3, then this one will carry cube, 1 over z, all into cube, which is 1 cube is 1, z cube is this. So z will reduce by 4, z, right? So this one will be what? Yeah, this one will be 1 over z raised power 4. Then the last one, z will be reduced by 5. There will be no z again. If you reduce the power by 5, that will be z raised to power 0 minus. So we don't need to write that. Then this one will carry what? 1 over z 5. So this is the expansion of this, but we are not yet done. Now let's use Pascal triangle to get the coefficient. Pascal triangle, if the power is 0, is you have 1. If the power is 1, if the power is 0, you have 1. If the power is 1, you have 1, 1. If the power is 2, you have 1, 2, 1. If the power is 3, you have 1, 3, 3, 1. If the power is 4, you have 1, 4, 6, 4, 1. If the power is 5, you have 1, 5, 10, 5, 1, 1, 5, 10, 10, 5, 1. Yeah. So 1, 5. For the power of 5, you have 1, 5, 10. So this is 1, 5, 10, 10, 5, 1. So that's the expansion. So you can just find time to go and watch my binomial. Then sit down with this expansion. You are going to get this. So this guy now is equal to 32i sine. Do we get? So that's where we are currently. Now, here now you have z raised to power 5. Bring this one together with it. Minus 1 over what? Z raised to power 5. Now, here you have this z will cancel one of this. So you have 3 left here. So this guy give you minus 5z cube. Are we together? So here, z here, 1. Z in 4, you have cube left here. Then you have plus 5 multiplied by 1 over z cube. See, I use 1z to cancel. You know, this one is 4 before. So I use 1. So I will have cube left here. That's it. So I'm gathering the cube together. Now here, if this one cancel this, you have cube left here. So plus here, this is we have z square. We remove 2, so you have 1 left here. So this one will be 10z minus, this one is z square. It will remove 2 out of this, you have 1 left here. Minus 10 multiplied by 1 over z. Do we get that? So z5 minus 1 over z5. This is z4. This is z. 1 z will be removed from this. This will cancel 1. You have z cube left here. Minus 5z cube plus. This is z4 here. Then you have 1z here. 1 will remove 1 from here. So you have 3 left here. 5 times 1. This one is already going to cancel 1 of this. 5 times 1 over z cube. This one is, we have z cube left here. We have z cube here. And we have square here. So z cube over z square equals to z. So this one will remain 10z minus. So here we have z square at the top. 10z square over this is z cube. So this cancel this. Then you have 10 over z. That's how we have 10 times 1 over z here. So equals to 32i sine this. Do we get that? So let me clean all this. So there is the Moivre's theorem. If you have z z minus 1 over z to be equals to 2i sine theta, then the Moivre's theorem says z raised power n minus 1 over z raised power n equals to what? 2i sine n theta. Sine n theta. That's what the Moivre's theorem says. So are we together? So now let's rewrite this guy. So let's rewrite this guy. This is z raised to power 5 minus 1 over z raised to power 5. What is common to these two? 5, right? Bring out minus 5. What we have left here? Z raised to power 3 minus 1 over z raised to power 3. No, minus times this, you have this. Minus times minus this, you have plus. So what is common to this one? 10 plus 10. What we have left here? Z minus what? 1 over z. Isn't it? Equals to what? 32i sine this. So are we together? So yeah, now don't forget this will change to minus because there is minus outside that will multiply it. No, we have plus there before. So using the De Moivre's theorem, let's see. If our n is 5, look at it. So this guy will change to 2i sine 5 theta minus 5 multiply by this one will change to 2I sine 3 theta. See, these are z minus z that we show initially, 2I sine theta. So if you have any, this one is not the same thing as z minus 1 over z all into 5. No. This one, the 5 is inside, 5, not outside. Assuming it's outside, that's the one we use binomial theorem to expand. So for the Moivre's theorem, if it is inside, then the n will be inside the angle of what is equal to. So if we have it like this, as this like our n, so 2I sine 3 theta. This like our n, 2I sine 5 theta. So plus 10. This one, since the power is just 1, it's just like the question. See, so this one will be 2I sine theta equals to what? 32I sine this. Are we together? So this gives us 2I sine 5 theta minus 5 times 2, 10I sine 3 theta. Plus 10 times 2, 20I sine theta equals to 32I sine this. Are we together? So now, what are we doing next? Since the question is sine theta all into bracket 5, so we are making this guy the set of the formula. So that means sine this theta is going to give us 2I sine this theta minus 10I sine 3 theta plus 20I sine theta divided by what? 32I. Yeah. If you divide both sides by 32I, this will cancel. So yeah, making this the set of the formula. So this is like the question given to us. So at the end of the day, we have 2I sine this theta divided by 32I minus 10I sine 3 theta divided by 32I plus 20I sine theta divided by 32I. Since they have common denominator, so we can split it, just like saying a plus b plus c over 2 is same thing as a over 2 plus b over 2 plus c over 2. So here I cancel I. 2 over 32, that's 1 over 16 sine this minus I cancel I. 10 and 32, here you have 2 in 10, 5, 2 in 32, 16 sine 3 this, 2 in 20, 10, 2 in 32, 16. I cancel I. Here you have sine what? Sine theta. What is common to everything? 1 over 16. So bring out 1 over 16. If you bring it out, here you will have sine this minus 5. No, 5 times 1 over 16, you have your 5 over 16. Sine 3 theta plus, this one will be 10. 10 times 1 over 16, you have your 10 over 16 sine theta. So this is the question. So even though we are given something like this in calculus and you don't remember reduction formula, you can't remember. So instead of using trigonometry to break this thing down, you can just use this method. It will give you something like this. It is very easy to integrate this, is it not? So this, what we just did, is a powerful tool even in calculus. So this is what we get. This like um product of multiple angle, because we have multiple angle inside, and this is a sine function. I can even say this is a sine and cosine function, because I can decide to add a 0 cos theta. It doesn't, but there is no problem about that. It doesn't have to contain cosine. It depends on the structure of the question. So this is the answer. For instance, now, though you are not integrating, for instance, if you want to integrate 1 over 16 is a constant, it will come out sine this minus 5 sine 3 theta. So the Moivre's theorem is a powerful tool. Like, it's a powerful tool. Very easy to integrate, like very much easy. Like, unlike this looks single, but is poisonous unless you use reduction formula. So neglecting reduction formula, you know that this guy is, even reduction formula, you still stress yourself. Yeah. So this is the answer. After 1 over 16, this is our answer. This is what we want. This is what they ask us to do. It's equal to it. You can plug in any angle. You can decide to plug in 30. So you say sine 30 all into power of 5. You see that it will be equals to 1 over 16 into bracket sine 5 times 30 minus 5 sine 3 times 30 plus 10 sine 30. They are equal. So that's that for that. Now, but what if the question says cos 5 theta? That place that we did z minus z, we would have done z plus z. You can back the video. So that place we do z plus 1 over z to give us what? 2 cos what? 2 cos theta. Do we remember? To give us 2 cos theta. So we now expand z plus 1 over z all into 5. It's going to give us z raised to power 5 plus 5 z4 1 over z plus 10 z cube. I will expand this, just that the sign will just be plus now because of this plus. 1 over z square plus 10 z square 1 over z cube plus 5z 1 over z4 plus 1 over what? z5 equals to 2 raised power 5 or 2 cos theta equals to 2 cos theta all into what? All into 5. The same process we did earlier, but here I'm doing, and I've shown us how this is equal to 2 cos theta. You can back it. So I'll just say this now will be equals to this, because if I say this is this, if I put this to power of 5, I will have to also put this to power of 5. But this one to the power of 5 is what I expand here, equals to this to the power of 5. So here, gather all the z together, they have the same power. Z plus 1 over z5. Can we see that? Here, z we cancel 1, we have 3 left here, plus 5z cubed, right? Here we have, here 1 we cancel out of this one, we have 3 left here, plus 5 multiplied by 1 over z cubed. So here, z square we cancel 1, we have only z here. We have 10z. Here, z square we cancel 2, rather, it cancel 2. We cancel 2, we also have only 1 z here. 1 over what? 1 over z equals to what? 2 raised power 5, 32. Then cos what? You can see we begat our question back. Now, the Moivre's theorem. If this is what? The Moivre's theorem says, if this guy is equal to 2 cos theta, then if we have raised power n here, this will be 2 cos what? N theta, isn't it? So this guy is going to give us 2 cos, because our n now is 5, 2 cos 5 theta plus, no, this one 5 is common to this, bring out 5. So here you have z cube plus 1 over z cube, right? That will be 2 cos 3 theta. 10 is common to these two, bring out 10. The inside will remain z plus 1 over z. Do you get? Which is same thing as us, z plus 1 over z. That's just 2 cos what? 2 cos theta equals to what? 32 cos what? Of theta. Do you get that? So at the end of the day, we'll be having 2 cos 5 theta plus 10 cos 3 theta plus 10 plus 20 plus 20 cos theta equals to 32 cos what? Cos 50 theta. So here, divide everything by 32. So that means cos 50 theta equals to this over 32. You have 1 over 16 cos 5 theta plus, no, we are dividing all this by 32, all this by 32. So this one, 32 already counts 32, you have this left. So if you are dividing all this by 32, this over 32, you have 1 over 16. This over 32, you have 5 over 16. Cos 10 over 32 equals to 5 over 16. Cos 3 theta plus 10 over 16 cos theta. So here you have 1 over 16 into what? Cos 5 theta plus 5 cos 3 theta plus 10 cos theta. So if the question is cosine, this is what we get. Can we see the beauty of this thing? Is beautiful. So just thanks for watching. Thanks for watching. I love you, my channel membership. I love you guys. See you in the next video. Don't worry, I'm going to give a lot that's going to help you in your exams, your tests, and everything. Thanks you. And always comment, always comment. I'm going to give assignment on this. Okay, let me give the assignment. Let me give the assignment now. Yeah, do for sine 6 theta and cos 6 theta. Yeah, do for this one. Yeah, using cosine and sine function and as a product of multiple angle. What we just did, do it for this one and submit on my Gmail. Gmail. Yeah, you all know my Gmail. Maybe I will drop it on the comment section. I think that should be tutor bello x dy dx dot at gmail tutor bello x dy dx at gmail dot. I think there is YouTube there. I will drop it on the comment section. This assignment, make sure you do it. If you don't do it, I will fight you. Sine 6 theta and this. Do it. Please, I'm begging you. In fact, do this one with it. Sine 4 theta and cos 4 theta. Do it with it. Do the 4. Thanks you. Thanks a million.